Hi class, so sorry that we can't do in-person lab today, but since I'm sick and since we have the ability to do an online lab, which is left over from COVID days, I am going to ask you to do this online lab. So you can download this lab in the module, and in module 3 it'll say lab 3 worksheet. And it's very similar to the lab we would have done in class, except you watch other people do the experiments and make your observations. So before you start the lab, go through this, the information at the beginning. The goals, you'll note, are to observe the physical and chemical properties. So observation is really important in this lab. Writing down clear observations and also balancing equations on classifying reactions. So because you're watching a video, you will be able to see bubbles, you'll be able to see color change. Sometimes, excuse me, you'll be able to see temperature change if they put a thermometer into the solution, but you won't be able to feel it yourself, get hot or get cold. You won't be able to smell things, and you might not be able to hear things, but all the observations you can make, please do make from these videos. And so they're going to talk in this lab. We learn about the difference between a physical change where the chemical formula of the stuff doesn't change, for example, when water freezes, or a chemical change when chemical formulas actually change. This is the list of observations they want you to do. Just do the best you can with the videos. And they also ask for each reaction, what kind of reaction was it? And they want you to tell us what kind of compositional change it was, whether it was exothermic or endothermic, like exothermic giving off heat, endothermic absorbing heat, and what are the behavior of the products and the reactant. For example, does a precipitation occur or does a neutralization occur? So in other words, when they ask you to classify the reaction, you have to make 3 classifications: compositional change, thermodynamic change, and product and reactant behavior. So make sure you come back to these table 2, 3, and 4 so that you can answer all 3 types of classifications, reactions. So in other words, the first way you need to classify something is by the compositional change. Is it a combination reaction where 2 things combine into a third different thing? Is it a decomposition reaction where some chemical falls apart into 2 different chemicals? Is it single displacement where you can see in this formula AB plus C becomes B plus AC? In other words, the A leaves the B and combines with the C. Or is it a double displacement where they both switch partners? And you can see these examples of the different types of compositional changes here. So then they also want you to classify it as exothermic or endothermic. So does the reaction produce heat? In other words, if it's taking place in a beaker, does the temperature of the beaker go up as the reaction occurs? Or does it go down? That would be an endothermic. If it goes up, it's an exothermic. If it goes down, that's an endothermic. Something starts to get cold, that's an endothermic reaction because it's absorbing heat from the surroundings to make the reaction go, so the surroundings get colder. Or the reaction is, the more common reaction is the exothermic reaction, where heat is given off because these 2 things have mixed together. And then finally, you have to classify it by type of behavior. So we have 4 listed here: precipitation, gas forming, acid base, or combustion. Combustion is burning. You'll see something burn. It'll be pretty obvious, but the technical definition is it combines with oxygen to make something new. And a common one is when you're burning a gas at a Bunsen burner, the methane combines with the oxygen, it burns, there's a flame, there's a lot of heat given off, and the methane and the oxygen turn into carbon dioxide and water. An acid-base reaction, you can basically tell by the reactants. If you're mixing an acid and a base, then it's an acid-base reaction. Okay? A gas-forming reaction, you'll see bubbles. If you see bubbles, then gas is formed. And when you see bubbles, you want to put the phase indicator as a G. So in this particular reaction, for example, and when you balance your equations, always put the phase indicators. Calcium carbonate was a solid. It was dropped into HCl, hydrochloric acid, which was aqueous. In other words, it was a water solution of hydrochloric acid. So when calcium carbonate is dropped into HCl, what happens? Bubbles form, and the calcium carbonate reacts with the HCl, and carbon dioxide gas is formed. Some more water is formed, and calcium chloride, which is an aqueous salt, is formed. You can't see that one, but you can see the bubbles. So that gives you a hint that some gas was formed, and looking that it started as a carbonate, it's a good guess that carbon dioxide was formed. The other type of behavior that you will see is precipitation reaction. Now this can be confusing for students if they aren't familiar with what precipitation is. Precipitation means you mix two chemicals together and a solid is formed that kind of falls out of the solution. But sometimes it doesn't fall out. Sometimes these little solid particles just float around in the water, and it just makes the water or the solution look cloudy. So when you see cloudiness, it's not really because the color of the chemical has changed. It's because a very fine solid has formed. And so any type of cloudiness, whether it's white or yellow or blue or green cloudiness, that means a precipitate has formed, and it's a precipitation reaction. The precipitate is the solid that forms from the reaction. So for here, for example, this one, they mix sodium chloride, that's table salt, with silver nitrate. And what's formed is silver chloride, which is a solid, and sodium nitrate, which is aqueous. So silver chloride doesn't dissolve in water. Table salt does, and silver nitrate does. Remember that AQ after the formula means aqueous. It means they've taken a solid and they've mixed it in water, and that solid is soluble. It dissolves in water. So an aqueous solution is something like table salt mixed with water. You can't see it in the solution, but it's there. Same with silver nitrate. You can mix that into water. It's soluble in water. So you don't use solid silver nitrate to do this reaction. Use an aqueous solution, a water solution of silver nitrate and a water solution of sodium chloride to do this reaction. That's what the aqueous means, and you always, always, always have to write these phase indicators. It's either going to be aqueous, solid, liquid, or gas. When you mix those two, it's two clear solutions. They mix together, but then silver chloride is formed, and silver chloride is a solid. So you'll see white cloudiness now in the beaker. And the sodium nitrate, this one, is aqueous, so it's just like salt water. It's clear. You won't be able to see that. Because you can't see it, you know that it's aqueous. But there's a list of different compounds that everybody knows are not soluble in water. They don't dissolve in water. So when they form, they're going to be solids. And that's how you figure out, oh, this is what happened. I got a solid. It was a double displacement. The Ag went with the Cl and the Na went with the NaO3. That solid's got to be silver chloride and not the NaO3, because I know NaNO3 is soluble in water. Okay. So here's an example. You watch the video, you see a reaction, you make observations. Okay, vision, what happened? The marshmallow turns white to brown black. Auditory, you can't. Smell. Obviously you can't smell through the video, so you can't put anything there unless the person who made the video says, oh, it smells like so-and-so, then you can put it in. Touch, again, you can't tell it, but if they put a thermometer in, or they say, oh, it's getting hot, then you can put that in as an observation. So you put in your observations for the reaction. You're going to have to balance the chemical reaction, which we'll go into a little bit later, and where then you're going to have to classify it by those three things. Don't do just one, do all three, unless there's not enough information in the video. Then say, for example, thermodynamics, not enough information given, or something like that. So make sure that you answer all these questions for each reaction that you observe on video. Okay, and I've checked all the videos. They all still work. So it says, what occurred during this chemical reaction and what were your observations? So what occurred, tell them what occurred, what you saw, what happened. Write the balanced chemical reaction, and then talk about what kind of reaction it was. Was it a, let's check back here, was it a combination, decomposition, single displacement, or double displacement? Was it exothermic or endothermic? Was it gas forming, precipitation, acid base? Sometimes it could be two. Sometimes it could be acid base and precipitation, or something like that. You never know. See, this one was the burning of the marshmallow is gas forming because carbon dioxide is formed and water vapor is released, and combustion reacts with O2. Okay, so we've got reaction videos, part 1. There's a reaction video. There's another reaction video. There's another reaction video. There's another reaction video. And then they talk about reactions in part 2. They ask you about reactions you're more familiar with, like a rusty nail or freezing water, and ask you to explain what's going on. And then they finally give you some reactions, and they ask again for compositional changes. Is it a decomposition? Is it a single displacement? Is it a double displacement? Or is it a combination reaction? You have to choose one of these for each one. You have to choose one of these for each one, and you have to choose one of these for each one in that question number 7. Because you see that they're telling you where the heat's coming. The heat's coming off at the end. This reaction, mixing nickel with fluorine, gives this solid and heat. So is that endothermic or exothermic? Is heat being given off, exothermic, or is heat being absorbed, endothermic? Same thing here. So they're asking for compositional changes and thermodynamic. They're not asking for the behavior changes in those two. But in this one they are, because you can read these phase indicators and see what happened. Oh, a gas. So maybe it was a gas forming reaction, right? This is sulfuric acid and potassium hydroxide, a famous acid and a famous base. Okay, and then you're going to have to balance these equations. So balancing equations is a whole nother video. I'm pretty sure I have some up there, and I also link you to one by Tyler DeWitt. Now I want to talk a little bit more about balancing equations, but before I do that, I want to show you that I have also included in the module this video by Professor Vince up there, who he made this video during COVID-19 to show how to do. Here's what a section of the video looks like at 11 minutes 30 seconds into the video. He does the full workup of this reaction, the observations, the balanced equation, the classification, thermodynamic, compositional, and behavioral. So he shows you how to do a sample reaction. So this is really good. At least start watching this video at 11 minutes 30 into the video. Do this lab, and he goes into detail about, he does an example with one reaction. Let me show you that real quick. So at 11 minutes or 11:30 minutes, 11:40 minutes into the video, he goes over this reaction of sodium hydroxide and copper nitrate. And he shows you what he would write as the observations for this reaction, what he would write for the balanced chemical equation for this reaction, and what he would write for the classifications, the compositional type of reaction it is, the thermodynamic type of reaction it is, and the behavioral type of reaction is. So he basically does all the answers for this reaction as an example. It's very, very helpful. Be sure to watch that. Starts at 11:30, 11:40 into the video. Okay, balanced chemical reactions. They can get complicated, and you guys are just learning how to do this. So how are you going to write these balanced chemical reactions? Sometimes you'll just get lucky. Like in reaction B, the actual reaction is written out there for you. They explain the whole thing, so you just have to copy it. What about this one? Say magnesium and oxygen gas. Well, the lab states you can look these things up on the internet. What is the reaction between magnesium and oxygen gas? or you can try to figure it out. Okay, for example, this is the reaction of magnesium with oxygen in the air. And if you listen carefully, the person who's doing the reaction gives you a lot of detail, a lot of observations about magnesium metal. And of course, you know what air looks like. So you can actually get quite a bit of information into your observation recordings from what this guy is saying. Then you have to write the balanced equation. Well, you've got metal and you've got oxygen.
What we're going to do is we're going to try to react this magnesium with the oxygen in the air.
So metal is a metal, and its formula is just Mg. It's just a solid metal. Oxygen exists as a diatomic gas. So I remember I have to put those little phase indicators in. It's a solid. Oxygen is a gas, and oxygen, I happen to know, and you will too, that oxygen exists in the world as a diatomic gas. It's O2. It doesn't exist as O, and that's a gas. So those are my two reactants. And then the product. Well, I don't know. What's the formula of magnesium oxide? It could be MgO. It could be Mg2O. It could be MgO2. And what the product is, you have to make sure you get the right one, because you get the product formula correct first and then you balance it. So which one is it? MgO, Mg2O, or MgO2? Well, at this point you might not know how to figure that out, but you can look it up on the internet. What is the formula for magnesium oxide? And here's the formula for magnesium oxide, MgO. So now we know what the product is. Now we can go back and balance the equation. So we've got Mg solid plus O2 gas goes to MgO. And you will see in the video and also in the Wikipedia that that was a solid white powder. Now we've got one Mg over here and one Mg over here, so that's balanced, but there's two oxygens on the left and only one oxygen on the right. Let me change colors here. So I'm going to put a 2 in front of the MgO. Now I have two Mg's and I have two O's. Back here I have two O's, so that's balanced, but I only have one Mg. So how can I fix that? I just put a 2 in front of that. Now everything is balanced. 2 Mg plus O2 goes to 2 MgO. Well, I hope this has been helpful. Good luck on the lab, and I look forward to getting your lab reports turned in. Take care. Have a great week. Bye-bye.